welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice, host of House of ZK Radio and education lead at ZKM. Today I'm joined here with co-host Pavel, who is DevRel lead at ZKM, and our guest Adrian, co-founder of Anoma and Namada. Thank you so much for being here today, Adrian. We're very excited to have you.
Thank you so much for having me.
Yeah, thank you. I'm wondering if you can first start off with an introduction of yourself. So your story and how you got involved in the Web3 space and then focused on ZK. And then I know that you had quite a few projects that you previously founded, like Cryptium Labs, Metastatic, before you went on to Anoma and Namada. So I'm also curious to hear about your why for your involvement in these projects and how it shaped your vision for the space over the years as well.
Yeah, let me give you the brief intro here. So I joined crypto in, 2016 or so, around that time, because I was looking for a topic for my grad thesis. And at the time, everything seemed very boring. Everyone was doing these like weird robotic things and autonomous things. And I was like, the Catalan independence referendum was happening at the same time in the Arab Spring, right? And so I came across Ethereum, was like, I could build it a censorship-resistant e-voting solution. I know the basic thesis that, if, 10% of the population wants to secede, it's pretty much a coordination problem. It's like not like any 10% can secede from any given country. That's not really a problem. It's mostly a coordination problem of how do you figure out that like another 9% wants to secede kind of thing. And so I wrote my grad thesis on censorship-resistant e-voting, came across Tendermint, the PBFT paper. And back in the day, we were a small community. I wrote a bunch of facility contracts, and I came across Tendermint, across Cosmos, messaged Jay on Slack, was like, this looks cool, do you need help? And then joined Tendermint or Cosmos as the third core dev. So built up that entire stack over a couple of years. So everything from Tendermint, now BFT, the Cosmos SDK, Gaia, the Cosmos Hub, IBC, and so on. Which is interesting. Nowadays, everyone is talking about these delayed block proposals, right? Like that. In Ethereum, we're now talking about we should do the transactions get ordered in block N and only get executed in block N+1, so you can immediately start gossing those onwards. Yeah, this was a very fundamental design choice that we put into Tendermint back in the day, because it seemed obvious that this should be doing. And so it seems like we're kind of revisiting a lot of these old core ideas. And then when was this, 2018 or so, I founded one of the first proof-of-stake validator companies in the world called Cryptium Labs. This is now also where I live in Switzerland, funnily enough. It was where do we put money, keys with lots of money on them? Well, the Swiss Alps historically were a good place for this. So the company was here, and we ran everything on physical infrastructure in the data centers here, which is funny because one day I rocked up to the data center and there were just tanks out front and a sniper nest on the roof. And it just turned out that we picked a data center that is considered core critical infrastructure for Eastern Switzerland. And so every 3 years, the army practices defending it because we're co-located with UBS and all the major Swiss banks. That was an interesting experience. Scaled that to 10 billion under management or so, ended up selling the company. For the newer listeners in the audience here, that proof of stake was going to be a thing was really not clear. In 2018, everyone thought we were nuts. Everyone was proof of stake, this will never really work. There was not a lot of activity in the proof of stake space, when we started the first validator there. But then sold the company. We very quickly realized, it is for 6 months building your own servers is really fun because it's I'm building my own computers again. I'm racking everything from scratch. And after 6 months, fuck, I know why AWS exists. This is why am I waking up on a Saturday morning to fix a hardware problem right now in the data center where I'm driving to Zurich to plug in a new cable. That was sort of the big foray into running infrastructure. And we always knew we liked protocol engineering and research much better. So we created a team called Metastate, scaled it to 15 people or so, and just ended up doing a bunch of protocol development. And the basic thesis for me was always, what are the three major components that every blockchain needs? It's distributed systems, cryptography, specifically ZK, and then compilers and programming languages. And so around this, we structured Metastate, focused on those three core areas, ended up doing a bunch of work with a number of protocols. And then really like in the middle of 2020, the space in the middle of 2020 was kind of weird. Like everyone was copying the same 3 Solidity contracts, so yet another EVM clone. And for some reason, this was supposed to be like a useful activity for the future of finance. And like there were some obviously glaring problems. Like users didn't have transactions, and they still don't. They have intents. They have like these partial state transitions that they want to like coordinate over with other people across the globe. The other thing was, and like you clearly needed generalized intents because you wanted to make these things very composable across many different systems. And this is like why I have some personal beef with people that are like, oh, these are just limit orders. Like, no, they are like arbitrary. Like a gnosis safe, that's an intent-based system. A roll-up, that's an intent-based system. Because it's always like the fundamental abstraction is like individual partial state transitions, and then you do some, like it's the outsourcing of compute essentially. The other big thing was like you needed some counterparty discovery solutions that were actually decentralized, right? Like right now, like Uniswap has kind of solved this problem by saying, well, we'll just do counterparty discovery in protocol. It's kind of like the dumbest, smartest way to do counterparty discovery. But it's actually decentralized, whereas a lot of the other teams were like, well, we just have a big server. So this was the other major challenge, like how do you get decentralized counterparty discovery going? And then probably like the third area was like, well, we need good privacy guarantees. Otherwise, I'm never going to be able to sell my parents or my family on the idea of using any of this tech if their neighbors see how much salary they're getting every month, right? And so the other interesting intersection with intents actually becomes there that like once you start thinking about intents, you start thinking about data living on edge devices, which is also happens to be the right model for like actual privacy preserving compute and scalable compute. Because if instead of having this large blob in the middle, we have a bunch of data on like edge devices and we just figure out how to coordinate correctly over this edge state, these systems become essentially scale-free. Yeah, that's sort of the super quick intro here.
Yeah, nice. And it was really great that you first started from that censorship-resistant e-voting system and then got introduced to some projects like with Tendermint and Cosmos. And it's very interesting how you mentioned that we're now revisiting some of the fundamental like design choices and considerations, like for example with Tendermint, and then also at that time you mentioned that there wasn't too much activity with proof of stake. And really great how you also mentioned your transition into focusing on generalized intents. I kind of wanted to dive more into the importance of these good privacy guarantees and wanted to hear about some of the current challenges that exist in our current privacy preserving solutions, and what you think the future of privacy looks like in both Web3 and then also beyond, and what role ZK plays in it.
Yeah, I think there's sort of like a very just practical thing, right? Like we need privacy for national defense. There is no world that I want to live in that like anyone really wants to live in where we outsource all the data mining to North Korea. This just seems a bad idea. So you need privacy guarantees, not for like, and like this, at some point I wrote a tweet about this, but like this is kind of the difference between the American preppers and the Swiss preppers, where the Swiss preppers are worried about the Russians coming and the American preppers are worried about the US government coming. And this is sort of like very much like the mentality that I think we have to adopt, which is like privacy is not like, if you live in a local environment, like you want to have a good system for community defense. This is like, honestly, this community national defense. I don't want to leak the entire Swiss financial system to North Korea. This seems like a tremendously bad idea, right? So like, I always approach these things from this perspective and like, how do I make my community more resilient? And so once you start thinking about this kind of stuff, you start realizing that a lot of the data is going to live in like edge devices, right? Like, it's kind of a weird thing that we currently have all this large state in the middle. It's super expensive to put it in the middle. It's super expensive to like synchronize this everywhere. It is actually much better if we just commit to some sort of state, but like the state actually lives in our end devices. And this is where privacy and like ZK and intents actually come in, where once state lives on edge devices, you need a way to communicate like state updates, right? That like if I would like to trade A for B, and like the state that I currently hold A only lives on my device, I need to be able to commit to this in ZK, just submit approval of the network, and then anyone else can sort of interact with this. The other really big thing to realize is that if you want to coordinate with people, so like once you start having intents, you need to reveal something. You can't keep everything private because you need to reveal something, right? Like if I want to do A for B, someone needs to know that I'm like willing to do A in a what size. it's all good and well if I like do a ZK proof over this intent and then like submit it to the rest of the world, and the rest of the world can't figure out anything here. So you need to reveal something. And this is, I think, a lot of where like our work on P2P stuff, P2P networks actually comes down to, which is how do you do partial information disclosure? So like I pick, for example, you, Alice, as like, I trust you and like I reveal some data so that you become a solver for me. But like, this is not that we need to structure the system that we fix the topology of the system, but rather like Anoma is very much topology agnostic. It's just designed to let users choose the topology that they care about. So if we all want to try, like if the world wants to trust Alice, that's fine, I can live with this. Whether this is necessarily a good choice, I don't know. Like I have my own opinions there, but like the architecture supports this, but it just supports that you can have many different topologies of the network depending on what users want.
Yeah, I got it. And it's very good that users have that choice as well. And I also wanted to ask a bit about kind of the dichotomy between localism and also globalism, which is something that I believe that you were focusing on and then trying to address within Anoma's design philosophy. So in applying like a globalism and localism to say protocol architectures to our governance systems, very curious to hear the types of scenarios and the factors to determine if a global solution or a local or more sovereign solution should be implemented. And I was also curious to hear about how your views on these global versus local approaches influenced Anoma's design as well, and how you guys kind of address those trade-offs.
Yeah, I mean, I would phrase this as globalism versus sovereignism. It is, and so very fundamentally, I hold the belief that like Bitcoin goes away on the eve of World War III. Because on the eve of World War III, most fiber cables are going to be cut, most satellites will be repurposed, if not shut down for military purposes, right? Like there's not going to be a ton of global bandwidth available to form like global consensus over some magic internet money. And this is fine. Like to me, this was always a hard design constraint that like getting global consensus and like getting global connectivity is sort of like an outlier. It is not going to be, I think, the standard that we can always assume. And so as a result, like we very much designed Anoma to work in this global environment if the global environment is successful, right? Like if the underlying networking topology allows you to come to global consensus, like just use global consensus if you want to. But like in case shit hits the fan, I want something that can actually like be a failover place for like financial coordination infrastructure, essentially. Like I would like to be able to like be in Switzerland and we use this technology, we use Anoma to do local coordination. And then as connectivity recovers again, then you can also use the rest of the global instances. But like the point was always that like you want to be resilient, and I think a lot of the crypto space has kind of lost this idea. But like originally, crypto was supposed to be resilient. It wasn't like if you had like these large single global servers, that wasn't the idea. The idea was that we can have many resilient systems in case the existing infrastructure starts collapsing. And I mean, we're now starting to see this way more than expected, I think, where it's like global infrastructure is just crumbling all around us, and we need these systems that can actually like be fairly nimble and like capable of adapting. The other big thing I think that most people don't ever really think about is that a like local system will always be faster. Like Solana, Anoma will always be faster than Solana. There's nothing Solana can do outside of like violating the laws of physics or like breaking some FLP theorems and consensus. Because fundamentally, if the three of us are in a room together, we should never do coordination via a global system. It's nonsense. Like why are we pinging a bunch of data to like servers in New York and San Francisco or Tokyo if the three of us are in the same room and we can just like plug fiber cables into each other's laptops? So like in this sense, Anoma will always be the fastest possible system, because like, but here the big thing becomes what specific preferences you have depends on like you. If you, for example, care about speed and low latency, you should do things as local as possible because that guarantees you the lowest latency. If you care about like you want global Ethereum security, if that's a hard requirement, then things will be slower, but you'll be secured by global Ethereum. And sort of Anoma works in both of these extremes and anywhere in the middle, where users get to choose, do they care about global Ethereum security, global Solana security, or do they care about local security or local speed, right? And so like this was what Anoma was always fundamentally designed around. And I think it's kind of it's kind of an oxymoron that we want to, all these chain maxis are pitching the idea of a one world government to me. And like, I didn't get into crypto because I was like, oh yeah, I definitely want to have this like one world government that runs all of it. And to me, like if you're a chain maxi, you're a one world government maxi. And like, honestly, I think none of the chain maxis want to be in a one world government scenario. But like crypto to me was fun because like it lowered the barriers to exit. And like the threat of a credible exit is the thing that keeps things working well. I don't want to be locked into the single global system. And the other big thing becomes like, not everyone has the same requirements for a security model. Like my parents will never trust Ethereum, no matter how decentralized it is. It's just like they want something that the local courts can overrule because that's what they trust, it's what they understand. If you live in Argentina, that's probably not the model that you care about, right? But like we've got to be building crypto to be actually like useful by the majority of the population, and that we can't really do by saying, well, there's this like single global thing to rule them all for various reasons.
Got it. And I think the point that you made on how crypto was originally supposed to be resilient and how there was this idea for many resilient infrastructures to be in place in case like the underlying infrastructure collapses, and it's very capable of adapting in that scenario. I think that that's very important. And I like how you also mentioned that trade-off. So for local, if users prioritize speed, low latency versus the global standpoint, if they say prioritize security more. And I like how you phrase it that users get to choose between these two extremes and also in the spectrum as well.
It's actually like the other thing is actually it's also a cost question, right? Like if to put all transactions, for example, like all trades into a single global security mechanism is just expensive because we now need to coordinate over, like we need to have global consensus over everyone's single trade. That seems really like it's just always going to be expensive. And for most things, I don't care about this. Whereas like if I can say, well, the World of Warcraft community just like runs their own Anoma instance and does their own local things, like those things never conflict with sort of like the global, stock trading systems. It's just like, and like I always have this, the way to explain this is kind of like you want to have culturally close things. Like cultural proximity matters because it's not about physical proximity. This very often becomes cultural proximity, but cultural proximity is just also like people that you do lots of interactions with. And like, if you do lots of interactions with people, you should probably be in the same zone, same model. If you don't do a lot of transactions with some other people, there's no reason why you all should be in the same security zone, the same sort of fundamental settlement zone. Because like, you don't have to be synchronous with each other. And so to that extent, I think, for example, if like the three of us actually don't trust each other at all, we may want to use global Anoma to do the settlement because this is like, it's the like most neutral global settlement instance. Whereas like if the three of us are in like all in New York or something and we want to do local settlement, we should do local settlement there. This is like, we have to like, I think to some extent crypto is kind of designed around the realities of the world. And like Anoma is much more designed to like be practically useful here and like be adaptable to be used by many different people in many different scenarios.
Mm-hmm. And it's really great that you mentioned that cultural proximity as well and how that trust component plays in there. I also wanted to dive a little bit more into some of the advantages that come with these intent-based systems. And curious to hear about the kind of the value proposition behind building intent machines versus ones that are solely VM-based. But then also wanted to hear more about in what ways can these intent machines enhance our current capabilities on our VMs and some of the applications or examples that intent machines enable that can't be just built on VMs alone.
Yeah. Like in the beginning with Bitcoin, we lived in this transaction-centric world fundamentally. And then at some point we're like, doing Bitcoin script is kind of annoying. We want to have more expressivity. So we then moved into this virtual machine-centric world. And this is the world we currently live in. And I think now, and like you're starting to see the same progression as you saw from Bitcoin to Ethereum, like people started to build sort of hacks around Bitcoin, like colored coins and Namecoin and you name it, because they were limited by Bitcoin. And currently, we're seeing this also, like people are being limited by virtual machines because they don't actually represent very well what we do on a day-to-day basis. Like if I want to sell some ETH for Sol, that's not a transaction. I can't sell this anywhere. I need to send this to someone prior to this. Like I need to like have some coordination infrastructure for this. And so these things aren't transactions, even though we currently are forced to model them as transactions. And this is where intent machines come in. And this is sort of like where really the third generation of with Anoma, and like I think there will be many Anoma-like systems in the future, comes in, where it's like it's just it's an intent-centric model. It's an intent machine. Some of the advantages, I mean, like fundamentally right now, if you want to trade some like ETH for Sol or ETH for Bitcoin, you either go via an AMM, which is horrendously capital inefficient, and it also makes no sense because again, you have this like single piece of global state that you all like, that's sort of the global lock on this. So it just gives you more flexibility. If you want, you can structure your things to like be locked by global consensus. But you know, if two people just want to say, well, I have A for B and the other person is B for A, you can just directly settle this. So the advantage becomes you can actually, like with Anoma and intent-centric infrastructure, you can just build a lot of the like what people consider the holy grail of applications that are fully decentralized without needing to build a bunch of your own backend infrastructure. Like when you think of like how do most rollups currently work, well, they run centralized sequences. Now they want to do decentralized sequencing, and they're building just a blockchain. I mean, this is what decentralized sequencing is, literally like you build a blockchain. No matter how you want to skin that cat, right? And so with Anoma, like you can just build, for example, decentralized order book exchange, and you just write the application, all the like P2P gossip. How do you discover counterparties? How do solvers fit into this model? It just comes for free. It's kind of like in Bitcoin, you could also, of course, build colored coins, build ERC20s, but it was difficult. You had to like fork Bitcoin Core and then make a bunch of adjustments and then like run your own thing. This is the major unlock with Anoma. I mean, on top of this, you also get all these privacy guarantees because Anoma is essentially just like one large ZK circuit. I mean, it's a recursive ZK circuit. This also applies to things like if you want to build a rollup. Well, a rollup is just like you combine 100 intents and you like do some compute to them, and then you settle to someone else. I mean, this is the right abstraction for this. So I think there are going to be a ton of new things that are actually going to be feasible now, without requiring that you run this on a centralized infrastructure. And I think this is really, really the big unlock here, that it is just much better infrastructure to build sort of super scalable applications. Because fundamentally as well, like currently everyone has to pick like, oh, do I want to be on ETH or Solana or Base because transaction fees matter? Well, in Anoma's case, they don't. Like if users want to be on Ethereum or want to be on Solana, they can make this choice independent of the application. Because Anoma is fundamentally this like distributed operating system for Web3, where you can treat the intent machine as one homogeneous operating system. And so you just deploy your application to the intent machine. And then whether someone wants to run this on Solana or Ethereum or global Anoma or in the local instance, that becomes a user choice. Like to a large extent, Anoma is just scale free because it depends on like where users want to run this. And like if everyone wants to run a global solver in New York because you want to like coordinate everything in New York, that's fine. And then you can just like run a really big server for this. But like this can scale fully independently of the rest of the system. And I think this is like, it's going to make developers' lives just way easier. I mean, it's a different model, but just like currently the thing is a fucking mess. Like you try to do things and you're like, what the fuck is wrong with you people? There's like 150 different things that I could be potentially on, and they all look exactly the same in a slightly different shade of gray. And like it's absolutely nonsense right now. And so like I think Anoma is really going to help with this.
And then diving into some more about the developer experience in general. I mean, you mentioned that with Anoma and these other intent-based architectures, devs can just write the application, and then all of the backend infrastructure as well as even privacy guarantees come for free, so they don't have to worry about those components. But also wanted to hear some more about maybe some of the other areas in which you really see the developer experience being impacted, and how it contributes to the developer experience overall, or if you offer any specific sort of tooling, any other specific sort of like tools for developers that really help contribute to that experience?
Yeah. So one big thing is that, I mean, the model is different, and like this is just the way it is, because it's a fundamental rethink of like how we should be structuring these systems. Currently, a lot of the systems are focused on compute, right? Like on Ethereum or on in all VMs, essentially, you focus on execution traces. You like the contracts you write outline the specifics, like the sort of computational steps, like +1 -3 turn thing grain. It's very imperative in its execution. Whereas in Anoma, it's much more sort of declarative. It's much more functional in that sense. Because in Anoma, you only care about the state layout. You care like, you say these are acceptable states for the program. You don't care how you get to the compute, which is also like you only care about like in the end, am I happy with the state updates? This also just like fits way better with ZK because you can use many different proving systems, you can use many different execution environments, because in the end you just verify that the end states are correct. And I had this interesting conversation with the CTO of Infinex in Korea, where he's like, because I was on a panel and I was talking about this, and he was like, yes, I think most people don't realize this anymore, but the web really took off when we moved from jQuery to React. Because we moved from this imperative thing that like fundamentally limited the complexity of applications that could be built to React, which was this very declarative framework, which was just like much more scalable in terms of how you can think about it, and the kind of application that allows you to build. And this is exactly the same move with Anoma, where it's like we're moving from this very imperative model to this very declarative model, where you just describe these are valid possible state outcomes, and you don't care how they happen. This also means, for example, that like an intent is just like I currently have state B and I'm willing to accept, I have currently state A and I'm willing to accept state B. What this fundamentally means is just that solvers can then go, well, I have these 15 things and together they form a correct state layout. Whereas in existing systems, it matters how you apply these things to update the database, right? Because like depending on how you interleave them, the compute may change. Whereas in Anoma, just like declarative state updates, and like they either commute or they don't commute. You don't have this problem that like, oh, how do I reorder these things to make the most money? Just like, are these things compatible or not? And like you can then put them into arbitrary orders. This also makes solving composable, which I think is going to be a long-term important feature, which is if you don't have composable solving, it just means that like there's going to be a mega solver, like a couple of mega solvers that everyone has to route via. Whereas if with composable solving, we can say, well, I have two intents, A to B and B to C. I collapse this into A to C and then send this onwards as another intent. And so you can actually use this as sort of like to represent a bunch of compute, which like you need to have shared compute over. And so I think in terms of actual developer resources here, so we also have a language called Juvix, which compiles down to our variant of Nock called Nockma. Which is Nock with a couple of extra instructions. Why Nock? Many people ask, well, Nock is super easy to write ZK circuits for. Anoma is just a recursive circuit where like the operating system is implemented in Nockma in that circuit. And so like Juvix targets Nockma. And so as developers, the nice thing is you can write your application in Juvix once, and when you want to swap out the proof system, you just swap it out. You don't rewrite your applications. It's just like high-level programming language that allows you to write applications independent of like the specific underlying execution environment. And so this is like, I think a lot with the developer tooling will come in. But I think over time we can also see many other languages targeting Nockma. But like the thing that needs to click in people's mind is like, it is way easier to build applications that are declarative rather than imperative, because it's very difficult to reason about imperative applications and how they compose with each other at scale. It is way easier to do this with declarative state updates. And you can like say, I'm willing to do A for B, and this could be on like either Solana, Ethereum, or Arbitrum, but not on Optimism. And then you just like send this out there, and this just starts composing across the entire ecosystem.
Also, just a point of clarification, would this declarative way also increase the security of essentially, since you're focusing on the end results and on the end action, rather than how it's actually done. Would that reduce like the complexity of handling these like mathematical errors or anything as a result of building on these imperative systems rather than just a single declarative one?
Yeah, this is actually an excellent point, which I forgot to mention. The number of possible branches that you have to consider when you look at these systems is just smaller, because you just focus on end results. You don't have to like focus on all the intermediary compute steps. So I would say at scale, over the longer term or the medium term, this is going to be more secure, simply because like it removes complexity. Where it's like we can offload complexity to the underlying operating system. And so we offload this complexity from like every developer to like, oh, we have to like deal with this complexity once and not every single time. Like currently we kind of live in this pre-Windows world where it's like, where everyone has to write specifically against like specific CPUs, and it's very difficult to do this securely. And I think with Anoma, it's like the first time that we can start writing against like the first version of Windows. And all of a sudden, like your application can just run wherever Windows runs. And not like, oh, I wrote my application for this Intel CPU, but you're using an AMD CPU, so good luck. Someone else has to build the same application for you again.
Got it. And I know previously you mentioned that you see Anoma as this kind of this homogeneous solution. So very curious to hear about the intention behind adopting this homogeneous protocol architecture, but then also having the idea of heterogeneous security. Just wanted to hear about how this differs from, say, some existing solutions that may adopt, say, a heterogeneous architecture or homogeneous security, and any kinds of limitations or trade-offs to consider between these different types of models?
Yeah, I mean, there's a bunch to unpack here, I think. Like, I'm pretty skeptical on homogeneous security for like the one world government argument. That like I don't want to live in a world where there's a single global security model. To me, that seems terrifying. The other big thing is like, I think the real world economy just doesn't work this way. I think it's a little bit naive to assume that like Switzerland or the US will issue their fiat currency on like a single global, like that they will give up monetary authority to a single global decentralized system. So like the realistic way to do this is like they either get a bunch of admin keys, but even that's like not a great model. The much better model is like honestly Switzerland issues the CHF on its own chain, and we pipe it into the rest of the ecosystem, and then we can use it as bearer assets, and like I can pump it into all the curved pools I want. But like I don't have to convince the Swiss government to just like adopt Ethereum over Solana. Like this is always an argument that we're never going to win, because both options are just ridiculous to anyone that thinks about like large scale sovereign systems. Same for like companies aren't going to adopt systems that like where they have to give up significant authority to some decentralized system that they can't really interact with. And we kind of sidestepping this always just like, well, we'll just add a bunch of admin keys, yeah, but that's not the fucking point. Like, and like we've improved very little. And so I think just the world is going to look heterogeneous. Like not everyone is going to like have the same requirements for a security model. And like we have to contend with this. This is, it makes our lives a little bit harder, but fundamentally this is the world we're going to live in. And then on the homogeneous sort of application or the homogeneous architecture, it becomes a question like phones are great because my phone, even though I bought it, I think somewhere in South America, works in China. And it also works in Europe, and it also works in Switzerland, and it also works in the US. I mean, it's magic when you think about it. Like, I'm not carrying around 15 different phones because everyone is running, because all like that, I need to have different phones for the different standards. Like, there's a huge benefit to the standardization, especially where like I can now build applications that span many different specific heterogeneous deployments. So like I can write an application that works on a global normal, one that works on my local chain that my parents like to use, that works in global Ethereum, and I can just like describe in code what kind of actually like state transitions do I want to authorize. There's a huge benefit to this. So I think this is really where this homogeneous architecture, heterogeneous security comes from, that this is the realistic way of the road, essentially. I mean, I could be wrong, but I don't think anyone in this space wants a one world government. I'd be very confused if they do, because I don't know. It just seems very not anti-ethical, but like it's the antithesis to the space, I think.
Got it. And it's good to hear that kind of the layouts between those differences as well. And I also wanted to ask you a bit more about the idea behind intent pools. And I know there's a couple of types, like those that are public versus private, permission versus permissionless. Just wanted to hear about their differences, maybe some limitations or opportunities that exist within those current distinctions, and how it fits into Anoma's intent system as a whole.
Yeah, so in the end, individuals should always be like, I can decide who I'm willing to send my intent to. I could just go like free. It's actually way safer in Anoma than in existing systems to do this like free for all. Just send it off because you've committed to a specific state transition. Like in Anoma, you can't really be front run. If you committed to like this specific state transition, no one can change this by changing the underlying, like by reordering a bunch of transactions in front of you, right? So you can do this free for all, but you can also say, well, I'm local here and I'd just like to do local settlement first because I'd like it to be fast and cheap. Maybe then after 5 minutes, if it's still not settled, I can send it off to a global instance. You can also see things where just specific subsets of the network specialize in specific intents, right? Like, I think it's going to be very difficult to build generalized solving algorithms. That problem seems to be NP hard, and like the first person that builds a generalized solver that's performant is probably like going to own the world. But I think it's unlikely that this will happen. But so like some solvers will specialize in like NFT trades, some will specialize in fungible token trades, some like in some other like long tail things. And so you can like decide, where do I want to send this? Or if you like care about local privacy, like, well, you may first gossip this only to like your local 3 trusted solvers. And if they can't, and then they are in charge of sourcing opposing liquidity for this. So that you don't have to reveal to the world what your intentions are. And so like these intent pools, like it just falls for free out of the topology of Anoma essentially, where like the users can make independent choices on like, do they want to send this to everyone? Do they just want to send this to like 3 trusted parties? Do they want to send this, for example, to a TEE? Because some solvers, I think in the future, Ilya from NEA has kind of red-pilled me on the idea of running complex algorithms in TEs. Like, so you have the ability to say, well, maybe the solver is running something in TE and I'll send my intent only to this solver. And so you just get this flexibility.
Got it. That makes sense. And then I also wanted to ask you more about some of the details about Anoma's protocol. Like I know that you guys incorporate the Anoma resource machine. So wanted to hear more about its role to the protocol itself. And then maybe some more details about what exactly can be derived from the resources or the life cycle of these resources. And I know that you guys also offer ephemeral resources as well. So I wanted to hear some of the scenarios in which, say, like a user would use the ephemeral resources specifically.
So the Anoma resource machine, this is honestly, it's Anoma, it's the operating system. So like what you would run in some global consensus, like what runs on the global Anoma L1, what you'd also want to deploy to Ethereum, for example, or to the rollups. It's Anoma, the operating system. You deploy applications to it. It is what verifies correct settlement of multiple intents. So when you like have a transaction, you have intents and then you combine them into a fully fledged state transition, then you submit them to the Anoma resource machine in the format of the Anoma resource machine, and then the Anoma resource machine essentially returns either true or false. It's like, it's correct or not correct. And so the Anoma resource machine, for example, has all the state layouts. So like it says individual resources are owned by someone, and like actually the resource model it's important to know. It's not an account model, it's not a UTXO model, it's in the middle. It's like UTXOs but with complex states. And like this also makes this very scalable because we can update the Anoma resource machine independent of each other. If like our 2 resources, like if I own some USDC and you own some USDC, we don't have to route via this global single ERC20 contract that it represents this global lock on that transfer. We can just rather like ship these resources around and assign them to someone else. And yeah, resource can be arbitrary in complexity, similar to how intents. Like intents are arbitrary in complexity. Just whatever you can express in code, you can write there. And so that's the heart of it, right? But then you have to think, well, we live in this heterogeneous world, and we need to have the ability to talk to someone, for example. Like I need to have the ability to decide, I need to send my intent to Pavel, for example, or to Alice. And like I need to be able to make this choice, maybe on some like on-chain metrics on like who has done some good solving in the past for me. And this is sort of where the entirety of Anoma comes in, like this distributed system part, like where we start thinking like, oh, how do we gossip these things around? What's the consensus like for like a global Anoma one? How do we hook in Ethereum or Solana or NEAR into the global Anoma one? And it's like by running sidecar, it's essentially running sidecars or adapters next to Ethereum nodes, where they bridge then the Anoma P2P gossip stack to like the Ethereum P2P gossip stack, and can say like, well, these intents were destined for like to be settled on global Anoma L1 or global Ethereum L1, and so like I'll route them to the correct nodes on the network, because fundamentally in Anoma all nodes are just like key addressable, so you can just like you can send things to pub keys essentially, and then those pub keys like the nodes know how to gossip onwards and how to route onwards a message destined for that specific pub key. The other thing I was thinking about is also like it allows you to set trust preferences, like local trust preferences on like, oh, I only want to talk to these people, but not those people. And then ephemeral resources is essentially like in Anoma, intents are free. You can quote an intent every half a second. Like the system doesn't care. Maybe everyone else will start blocking you if you spam them. But there's no reason why you shouldn't be able to quote things every half a second, for example, if you want to update a price feed. And then you can just say that, well, these intents expire. So they expire on the next block, for example, for global Anoma 1. Or so like some larger block. Maybe there's some trusted sequencer or like some trusted 6-node network that says, well, we'll expire, we run half a second in block times, and all intents just expire after half a second, right? This is fully compatible with Anoma, and this essentially just comes down to the topology of the actual deployment. The coolest thing, though, is, and I think most people don't realize this, currently we're living in this world where, like, I'm a different, like, class of node on a global blockchain. Like, I am not a node on Solana or on Ethereum or in any existing system, right? Like I have to like talk to an RPC to get some data, then maybe I send some transaction to write some data. In Anoma, like the thing just runs on your phone. Like you running a local 101 Anoma node on your phone, and you just all sit, like everyone just sits on the same P2P stack. There's no distinction like, oh, some users have to talk to the rest of the network via RPCs. It's just everyone sits on the same RPC, on the same P2P stack, and we just like all like different types of nodes. Some nodes will do consensus, some will only care about like my local balance and will listen only for like local balance updates to my local state. Like the end dream here is essentially that I can also define like these 3 or 4 devices are me. And then these 3 or 4 devices figure out how to synchronize state between each other using Anoma. Where it's like, we know how to like back up state from like a laptop to a phone if both things are online. And like instead of having to move manually a bunch of state around, all these state updates just happen in the background because I have to find like these 3 things or these 4 devices are in my local trust zone and they actually represent me. Yeah, like the hope is that honestly we can get rid of like the 150 different wallets for every single application, and instead go like, there's my Anoma node, and I know how to talk to Ethereum for my Anoma node, and if I've like synced a bunch of private state to my phone, it also automatically like syncs over Wi-Fi to my laptop if I want to switch.
Got it. It's a much more streamlined, much more uniform process. And just as a last question before we close, I know that you guys relatively recently had your DevNet launch. Wondering what builders can expect with that recent launch, how that phase kind of fits into your broader roadmap, and also if you want to mention any other kinds of announcements or closing thoughts to the audience. But yeah, just wanted to hear about like the current state of things.
Yeah, stuff's cool and cooking. So we open sourced Anoma maybe like 2 months ago or so. So it's all written in Elixir, and like So if you just want to run things locally, you can. I mean, in the beginning, it's like they're rough edges, but generally speaking, the entire system works. You can run it locally. You can build intent-centric applications. They're fully composable, like you have fully composable intents, and you can run them right now. We launched a private devnet to like have a small group, to help small group of builders essentially get up to speed and like really help them along. And there's like now 6 or 7 teams in the pipeline that are just building very cool applications. So if you're a team there that like wants to actually for the first time build intent-centric applications with fully generalized intents, like hit us up. It's cool. But of course, if you also just want to fuck around with the software and like try things out, like follow the docs, it's all open source code. You can do it yourself. There's like no permissioning here that's required. What's coming up next is actually the public DevNet, where sort of like all these teams can start talking to each other, like all these applications can start interacting. And then like launch, like towards the middle of the year, we're targeting that Anoma actually goes live, and that you can like do things with real value and real apps. And so yeah, that's sort of the next big things that are coming. I think like to me the biggest thing, if you just want to copy the same 3 contracts to yet another chain and for some reason consider this to be useful activity, like Anoma is not the place for you. If you want to do like actually cutting edge stuff that like matters long term, like come to Anoma. There's no better place than Anoma to like just try applications and actually see if we can like build infrastructure that changes that is not just like this incremental improvement to sort of the existing infrastructure, but that's fundamentally groundbreaking. I mean, like, I don't know, like I joined the space not because I was like, oh, I hope I can build 10% more efficient financial applications. I was like, we can build cool things that aren't possible right now. And like with Anoma, we're going back to those roots. So like if you want to like do very exciting things, check out Anoma.
Nice. Really love that vision. And yeah, thank you so much, Adrian, for joining us. Enjoyed overall about hearing this idea of generalized intents, and then how you guys focus on that declarative approach and that homogeneous model. Also really liked how you give users that choice in terms of, say, versus like the global versus the local approach, and how devs can now focus on building that application versus worrying about that underlying backend infrastructure. So really enjoyed hearing about all of these insights from you, and really appreciate for you being here today.
Of course. Thank you so much, Alice, Pavel, for having me.
Yeah, thank you so much.
Thank you.